Welcome back to the Deep Dive. Today, we're exploring a really interesting corner of the mathematical universe.
Indeed. We're focusing on the online encyclopedia of integer sequences, the OEIS.
Right, an absolutely essential tool for anyone studying number theory, I'd say. It's like this huge library of number patterns.
Exactly, a treasure trove, really.
And today, we're zoning in on one specific entry, sequence A000202.
A fascinating sequence. We're going to unpack some of its properties and see where it connects in the broader mathematical landscape.
Sounds great. So let's get started. The sequence A000202 kicks off with 1, 3, 4, 6, 8, 9, 11, 12, 14, 16, 17, 19. Now, just looking at those numbers, there isn't an obvious simple rule that just jumps out at you, is there?
Not at first glance, no.
Yeah.
It's not arithmetic, not geometric in a simple way. But as often happens, there's a hidden structure.
There usually is. So what is the underlying logic here?
Well, the OEIS entry gives us a key, a recurrence relation.
Okay.
It says that AI plus j is equal to 13i plus aj, and this holds for j from 1 up to 8.
Right, so it relies on the first 8 terms.
Precisely. Those first 8 terms, 1, 3, 4, 6, 8, 9, 11, 12, they're like the building blocks, the base ingredients.
Okay, let's make that concrete. How would we find, say, the 9th term using this rule?
Good example. So for the 9th term, n is 9. We write 9 as 8 times I plus j. That would be 8 times 1, so I1.
Plus 1, so J1. Got it.
Exactly. And we know AJ, which is A1, the first term, is 1.
Right.
So the formula says A9 equals 13 times I, which is 1, plus AJ, which is A1 or 1.
So 13 times 1 plus 1. That's 13 plus 1 equals 14.
And if you look back at the sequence list,
The 9th term is indeed 14.
okay, that's quite neat. It lets you build the sequence out indefinitely.
It does, step by step. But,
Yeah.
sometimes you want a shortcut.
Yeah, you don't always want to calculate terms 1 through 99 just to find the 100th term.
Exactly. And that's where a closed form formula is incredibly useful. For A000202, there is one.
Oh, why?
It's given as AN equals floor, 13n18.
Floor, so the greatest integer less than or equal to the result. Correct. So you just plug in the n you want, do the calculation, take the floor, and boom, you have the nth term directly.
That's much more direct, like taking an elevator straight to the floor you need instead of climbing the stairs.
A good analogy. It really shows the power of finding these explicit formulas.
What often fascinates me most is how these sequences, which seem to live in their own little worlds, sometimes connect to others.
Ah, yes. The interconnectedness. It's one of the beautiful things about mathematics.
And A000202 has a connection that's, well, pretty surprising, doesn't it? It links to the Fibonacci numbers.
It does. A truly remarkable link. The Fibonacci sequence, A000005, in the OEIS, of course.
So what's the connection?
The OEIS entry, citing work from the 80s, states that for m greater than or equal to 6, A Fibonacci n-1 actually equals Fibonacci n plus 1, too.
Wow. So you take a Fibonacci number, subtract 1, find that term in our sequence, A000002.
And it relates directly back to the next Fibonacci number, just minus 2.
That's unexpected. It weaves together this sequence with arguably the most famous integer sequence of all.
It really does. It hints at deeper structures, hidden relationships that aren't obvious on the surface, like finding a secret path between two islands you thought were completely separate.
Absolutely.
Yeah.
Are there other structural insights the OEIS gives us about A000202?
Yes. It also mentions that the sequence has a linear recurrence with constant coefficients.
Okay, that sounds a bit technical.
It is, a little. But basically it means each term can be calculated as a specific fixed linear combination of some number of preceding terms. The OEIS even gives the signature for this recurrence. 1, 0, 0, 0, 0, 0, 1, now 1.
So those numbers tell you how to combine the previous terms.
Essentially, yes. It's another way of defining the sequence's structure, emphasizing how terms depend on earlier ones in a very specific pattern.
It's amazing how much information is packed into one OEIS entry. It also notes the history, right? This isn't a new sequence.
Not at all. It was included in Neil Sloan's original Handbook of Integer Sequences back in 1973.
Right, and the later encyclopedia integer sequences too. So it's been recognized as significant for quite some time.
Definitely. And even before the handbook, problems related to the sequence were appearing in publications like the Fibonacci Quarterly back in the 60s and then again in the 80s.
So sustained interest over decades.
Yes. It shows it wasn't just a fleeting curiosity. Mathematicians have been engaging with its properties for a long time.
The OEIS entry also seems careful to point out that A000202 is not the same as some nearby sequences, like A000201, or A00066096.
That's also a crucial function of the OEIS. It helps differentiate. You might find a sequence that starts similarly, but the OEIS clarifies the precise definitions and distinctions.
Like providing coordinates on a map, showing this sequence, but also its distinct neighbors.
Exactly. It prevents confusion and guides further exploration accurately.
And for those who want to, well, actually compute the sequence, the OEIS often includes code.
Yes, for A000202, there are snippets provided for Maple and Mathematica.
So you can generate the terms yourself using software.
Right. It bridges the gap between the abstract mathematical definition and concrete computation, which is great for experimenting or verifying properties.
So wrapping this up then, we've seen A000002 defined by a recurrence relation using its first 8 terms.
The step-by-step method.
And also by a direct, closed form formula involving the floor function.
The express elevator row.
Plus, this really quite stunning connection to the Fibonacci numbers.
Which hints at deeper mathematical currents.
And we touched on its linear recurrence properties and its history within the OEIS and mathematical literature.
Don't forget the computational aspect and its distinction from neighbors.
Right. It really showcases the richness you can find in just one OEIS entry.
Absolutely. The OEIS is just an incredible resource for seeing these patterns and connections unfold.
It really is. This deep dive has been fascinating. You know, thinking about these different ways to define A000002 and 8, the recurrence, the formula, the Fibonacci link, it makes you wonder, doesn't it?
How so?
Well, what does having these multiple descriptions tell us about how mathematical ideas connect? How looking at the same thing, this sequence, through different lenses can enrich our understanding?
That's a profound question. It suggests mathematics isn't just a collection of separate facts, but a deeply interconnected web. Different definitions are like different paths leading to the same point, each revealing something unique about the journey and the destination.
Maybe that's something for you, our listener, to ponder, and perhaps even explore further on the OEIS itself. Check out those related sequences we mentioned, A00000201, A00666096, A000008, and naturally A000045 for Fibonacci, but also others listed like A00001099, A00000203, and so on. See what other connections you might find.
There's always more to discover.
Indeed. Thanks for joining us on this deep dive.